This is question. As you can see, there are two questions in front of you. Question is asking, question is to factor it. Question is to factor it, but by using common methods. Okay, by using method of a common factor, you will have to find common. Okay, it can be number, it can be coefficient number, it can be constant number, it can be variable. Okay, whatever you are observing, that this is a common, that is a common, this is a coefficient number is a common, this is a constant number is a common, then just take that number as a common. So here in front of you there are two questions. We will factor it by using method of a common factor. Let's start from this. 5x plus 20. Now here as we 5, we can take 5, isn't it? Because here 5 ones are 5, it will become, here 5 fours are 20. So this is a product of 5 multiply. This is product of 5 into 4. That's why 5 I am going to take it is going to be 5 as a common. Now here x as it plus as it. Now how much should I write here, from which I will get how much? 25. So for 5 for the 20. That is how you will factor. Now even you can check. When you multiply this by this, then you will get 5x and plus as it. And now it's time to multiply this by this. So 5 for the 20. So till here it is correct. This is equal to this, isn't it? This is equal to this. Clear? Now what about next? Till here, that's it. We have done factor. We have done factor. Factor it. Now next, this. In this you can see, in this question we took 5, which was a coefficient number with the x variable, and here we took in this question what 5 as a common. Now in this question you will realize that you will be taking variables as a common, because of variable will be common. That's why here first of all 3 1 is 3, 3 2 is 6. So 3 can be taken as a common. 3. Now what else? Here x square, and here is only x. So only x we can take x, because hold on, and now here y and here y as well. In both terms there are 2 y's, so that's why I am taking only one y as a common. Now this is 3, so I will write nothing as a number. Now this is x, this is x square. So here x is a 2 times, but here x is a 1 time. That's why 1 time more I will have to write here. Y is a 1 times and y is here 1 time. So it is clear. Now next term minus as it. Now 3 2 is a 6. It will become 6 is a product of a 3 multiplied 2. So 2 x both are clear. Now here is a y, here is a y square. It's a 2 time and it is a 1 time. So that's why we will write here y. Now it will become 2 times. Clear? 2 times. That's it. So you would say this is common. This is common. We took this as a common. Clear? That's it. That's it. Now next question. This is complete question. Same in this question. See, look at this. Where is common? What is the common? Okay. Here it is coming in the table of 3. This is also, and this is also. Here 18 is coming in the table of 2, but 27 is not coming in the table of 2. 36 it is coming. But what about this? This is not coming in the table of 2. That's why 2 will not be common for this 3 terms. Yes, 3 can be common for this 3 terms. 3 9s are 3. It is coming in the table of 3. 27 is coming in the table of 3. 36 is coming in the table of 3. So we can take 3 common. Now here AQ, here A square, and here A square. So of course we will take what? A square. Not only A square. How much? A square. Now here BQ and B square. So we will take how much? B square. Less components we will take as a common. Clear? Now we can say we took this as a common from this. Now 3 is here. It is a product. So it is a product of 3 multiple. 3 multiple I think 6. 3 multiple 6 will be product of 18. A square and here A cube. So only A we will write. Why? Because A square it is a 2 times, it is a 1 time. When we multiply both, then it will give us A cube. Now what else this? A square, okay, A square. This is a 2 times, this is 1 time. When we multiply this both, it will give us B raised to power 3. Now minus 3 9s are 27. Now you can see 27 is the product of 3 multiple 9. Clear? A square, it is a square. Both is the same. We don't have to write. We don't have to write this because both are same. Now BQ and B2. So here B2 and BQ. Only we will write B. Now when we will multiply this, then it will give us BQ. Clear? BQ. Now it is clear. Next, I think it is a product of 12 multiple 3. 3 to the 6. 12 3 to the 6 and 3. Yes. Why did we write 12 here? Because when we multiply 3 by 12, then this both will give us 36 by multiplying. Now here is A square and here is also A square. So we will not write because of both are same. B square, B square. Again this B values are same. Now this is common in this question. So we have done factor. So till here this is answer. Now, even you are thinking, even you are again, if you are observing that here more thing can be taken as common, then you can take. Okay, because I am observing that here this is coming in the table of 3. This is also coming in the table of 3. This is also, but it is coming into the table of 2. It is not coming in the table of 2. It is coming. So here these 3 terms are coming in the table of 3. That's why 3 will be common for each this terms which are in the bracket. So here only I think 3 multiple 3 A square, B square, isn't it? Yes, because of here is not A, here is not A, Here is a, yes, here is not a, here is not a, here is not b, here is not a. That's why we cannot take again what a, b, c any variable as a common. Now here 3 2 is 6 minus as it 3 3 is 9 plus 3 4 is 3 4. We will multiply this 3 3 is 9 a square b square 2ab minus 3b plus 4. Not till here this is also. Here now you can observe that it cannot be simplified. It cannot be simplified. Here in this bracket we cannot take any number or coefficient number or variable as a common. That's why. So forward it we cannot simplify it ahead of it. Now next. This is computation. What is it asking? You have to factor it, but by using method of common factor. Here you can see this and this are commons. Outside terms we can write in one bracket, and these are two times. That's why we will write it one times as a common. 2x minus 3. So this was common in this equation, in this linear equation. Clear? That's it. Clear? That's it. When you will simplify it further, then you will find this same. Yes, it will happen. Now next same question. This is question. Here, just observe. Outside terms. First of all, just write outside terms in one bracket. This is one. This is the second term. So 2m plus 3. We are writing these terms in one bracket, which were outside terms. Now this is common. This is same. This is same. That's why there are two, which is the same. We will write it one times as a common. That's it. Clear? That's it. Now next question. Look at this question. What is the same? What is it saying? This is we have two questions. We have to use what? We have to use same common method. But here you are observing what you have four terms in one question. You have four terms in one question. Here you can do one thing, is that just regroup. Okay, regroup. Just make a group. of a common. You have to pattern, but using a grouping method. You have two questions. No. Here is a square. In this term is not a. In this term is a. You can take it, otherwise you can take it. A square plus AC. I am decorating it so that we can think clearly. Now, whatever you have left, you can write this here. BC plus AC. Now, you can easily say that here we can take A as a common. In this, we can take C as a common. That's why I decorated in this way. Now A, I will write here A because it will give us A square. Now this is already A, only C I will write. Now here, as you know, it can be written as here same. Now here is AC, so it will be what? AB, isn't it? AC. Yes. Now here you can say C plus C. Now here, what can we write here so that this can give us BC. So of course only we can write B. When we multiply this by this, it will become BC and BA. Clear? Now outside terms, A plus B. This is equal to this, C plus C. Even you can write A plus C. Both will be equal. This is answer. This is answer. So what did we do? Just we decorated it so that something can be common. Now from these two terms we found A as a common. From these two terms we found B as a common. Now outer terms we wrote in one bracket and these two brackets were same. That's why we wrote here only in one bracket, only one bracket by taking common. Now here ax square, okay, and now here it is ax square, it is x square, so we can write this together, ax square plus bx square, like that. Now whatever you have left, you can write b square plus ay square. Now as you are thinking, it can be taken as common, that's why we have decorated in that way. X square a plus b. Now when we multiply this by this, it will give us this. Multiply this and this, it will give us this. Now we can write this here. In this case, what is happening? Y square is common. Y square is common. Y square multiply A, it will give you ay square plus, otherwise you can write y square b plus a, y square into b, by square, y square into a, ay square. Now outside terms, x square plus y square. Now a plus b. These are outer terms. I wrote in one bracket. This and this bracket both are same. That's why both can be written as only one times. And I wrote here till here. So here I applied a regrouping method. Where? Here. Regrouping method. I saw that x square is here, then x square is coming in this term. In this term, x square is not coming. X square is not coming in this term. So here x square I can write as a common. That's why I shifted it here with this together. Now in this we can easily see that y square is common. Y square is both terms, and as you know, y square, if y square is in both terms, so it can be taken as a common. Clear? Now next question. Carefully solve it. Carefully solve it. What is it showing you? Now let's start from this. It will be different, but you can understand. You can solve it with logic. Now here already it is a decorated. It is a decorated. We have regrouping decorated at all. Here x can be taken as a common, a plus b. Now here we can write a plus b. Now y is a common, so can we write minus y? Here you can check easily. Okay, if you don't believe that I am thinking it could be wrong, our answer could be wrong, then you can check. Multiple this by this, you should have this. Multiple this, then you should get how much this bx minus ya, okay, minus plus minus, okay, y multiple b dy, outside terms, and this as you know both are same. That's why one time it is written because of both are same. That's why till here this is answer, till here this is answer. Clear? Now in this case, that's it. It is not difficult. It is not that difficult than you think. Okay, than you think. It is not that difficult. Now here in this case, z minus 7. In this x y z, x y, it is a common. Yes. Can I say 1 z minus 7, z minus 7? Yes, 1. Now if we write here how much, minus, not minus, plus only, plus not minus, yes, minus what else? Here is a z, xy and xy we want, xy. Here you can see xy multiple z, minus xyz you will get. So here minus xyz we wanted. Now minus plus, okay, 7 multiple xy, 7xy you are getting. So till here it is a correct. We can confidently say that it is correct. Now what is outside terms? Right, you write outside terms in one bracket. 1 minus xy z minus 7. Clear? That's it. That's it. If you wanted to check, then you can check as I told you. Next question. You have this question. Now you do you know what is it? A square plus 2ab plus b square. A square minus 2ab plus b square. These are known as algebraic identities. Okay. We will apply this. We will apply this. One thing more. 4a square minus b square, we can write it as a minus b. A minus b, a plus b. We can write it as a plus b, a minus b. We have three algebraic identities. We will apply this on our question. On our question. Now here we have two questions. We will apply this algebraic identities. You can see how. If you think that here we can apply this algebraic identity, then you can apply so that you might be thinking that why do we need to apply this. If you are thinking that this algebraic identities can be applied in your question, then apply. Then you apply so that you can save your time. Logically, you can solve any question. That's why identities are applied in question. Now x square, okay, we can write it as x square plus 2. Here we can say a square plus 2ab plus b square. It is a perfect square of a number. Yes, that's why. That's why now we are confirmed that algebraic identities can be applied in this question. 2 multiple 4, it will give us 8, 4 and x plus it is a perfect square of 4, 4 for the 16 years. Now as you know, it is known as a and it is known as b. It is known as 2, it is known as a, it is known as b. So finally you can say a is how much? X. And b, where is b? B is this, x plus 4 in whole square. This was answer, and we brought what question, x plus y square. Now you can use this formula. When you will use this formula, then from here you will find this much. Clear? Now in this question, 25 is the perfect square of 5. That's why we can write like that. Clear? Plus 2 multiple. Now how much will we write here that that product of two multiple that unknown number will give us 30. So 250, 2 multiple 50. In so hold on. This is 5. Yes, this is 5. Clear? Now here this is a perfect square of 3. 3 square. As we know 2 multiple a multiple b. So this is a we have written here a, and now b. B is how much? 3. Clear? 3. Now here in place of a is how much? 5a. In place of b is how much? B. In place of b is a 3. It is a in a square. It is in a square. That's it. That's it. Here we applied what algebraic identity is this. Clear? Now, if you don't believe, then yes, when you apply this formula, then from here, then you will get this same. Clear? This is same. Now, how to check that we can apply in that question? What we can apply this algebraic identity? How to check? It is a main question. Look, if this side, this first term is coming as a perfect square, of any number, then yes, we can. One more thing. What? Last term is a perfect square. Then now you can use algebraic identity to factor it. Clear? Now next question. Now I told you how to check that algebraic identities can be applied in our question. Just look. First term, look at the first term of this question. It is a raised to power 4. It can be written as a square raised to power a square, isn't it? A square raised to power a square. As we know, it is a exponent rule. Exponent rule says just multiple. If both are exponents, then just multiple them. 2 multiple 4 will give 4. 2 multiple 2 will give you 4. Now here plus 2. Here you can see this is a square. Here is a square, so it will be as it. Now look at the last term, bs. It can be written as b square raised to power 2. Now it is this is in place of a and this is in place of b. 2 multiple a square. It is a value of a. Now value of b is how much? B square. Clear? That is how you solve question. You factor. Now, as we know, this is a value of a and this is value of b. A square plus b square. It is in all square. That's it. This is answer. This is answer. This is a perfect square of a square. This is a perfect square of b square. Now in this question, 4y square. 4y square. So of course 2 is the perfect square of 4y is the perfect 4y square. It is a perfect square of 2y. It can be written as 2y multiple 2y. Yes, then it will give us 4y as well. So 2y raised to power 2 minus 2 multiple what else? Leave it here. Look at this. It is a perfect square of a 3. 3. Clear? Now, this is a value of a b and this is value of a a. So we will write here a multiple b. 2 multiple a multiple b. 3. Like. Now as you know that this is a and this is a b. But hold on. Here subtract is coming. That's why we will apply a subtract. Now it is in whole square. That's it. Now here you can see it is what a square minus 2ab plus b square, and it is what here it is what a square plus b square plus a square plus 2ab plus b square, isn't it? So here we applied algebraic identities. By applying algebraic identities, we did factor it. Now next question. Next question, you can feel different from the previous. Here you can see we have 3 terms. In this question we have 2 terms, but don't confuse, okay? Don't get confused. You can easily solve it. Just carefully look at. As I told you, look at this first term and look at this last term. Are these terms giving you what perfect square or not? If yes, then we can apply algebraic identities here. And here, look at same here. Look at the first term and look at the last term. It is giving. Is it giving to you as a perfect square or not? Then tell me. Try to understand this question. Yes, it is a perfect square of 11. It can be written as 11b raised to power 2. It will give you 121 b square. Now, we can leave it for few seconds. Okay, here, look at this. It is a perfect square of 4. It can be written as 4c raised to power a square. Clear? Now, as we know, it is a value of b, it is a value of c. B, it is a value of a and it is a value of b. 2 multiple 11b multiple 4c. This one term will give you this much. You can multiply this. 22 multiple 4 88 and BC as it minus as it. Yes, That's why we say that it is a correct. This word is one term, this word is another term, this word is one term. We can easily say it is a value of A and it is a value of B. And here subtract is coming. Subtract is coming. It is in hollow square. It is in hollow square. That's it. Till here it is the correct answer. Now, question is what? What did we do? We applied here algebraic advantage because of it was giving the first term of the equation was giving us a perfect square, and now last term of that equation was giving us as a perfect square. That's why we were able to apply algebraic advantage. Now in this case, what is happening? It can be written as 7p raised to power 2. It is a perfect square of 6, isn't it? Yes. Now here, one another algebraic parent is, as you know, a square minus b square. It provides what? A plus b into a minus b. Even you can check when you will multiply this. When you will multiply this, you will get this a minus b plus b, a minus b. You can multiply a square minus ab plus ba minus b square. This will cut, and finally you are getting a square minus b square. That's why. So you can say a square minus b square can be written as a plus b, a minus b, because of here minus is coming because of here is minus. So minus comes when there is a combination of two operators of a different, like minus, plus minus. Okay. Here it is a value of a and it is a value of b. So 7p plus 6, this is 1, and 7p minus 6, this is another one. That's it. Even if you don't believe, then you can solve it. You will get this much. You will get this much. I think this much. If you don't believe, till here this is answer. 7p can be written 7p minus 6 plus 6, 7p minus 6. Just multiply. 7 49 p square. Yes, you are getting this. Minus 42 p plus 42 p minus 36. Now you can see this will cut. You are getting 49 p square minus 36. This is equal to this. That's why this is correct. Clear? Now next question. Next question is this is the next question. Now look at this question. Here 63 is not a perfect square of any number. Here we can take a common we can take common. 9 sevens are and 16 sevens are 4 7 4 11, yes 16 7 and 9 sevens are 63. So here 7 is a common. 9 a square minus 16 7, 16 7. Why did we do like that? Because of here it will provide us 9 is a perfect square of 3, 16 is a perfect square of 4. That's why we did like that. Okay, here 7 will be as it. 7 will be as it. We will not do anything with this is 7. Here we are observing what we can apply algebraic identities in this bracket because it is a what? A square minus b square. So here it can be written as this much minus 4a square. Yes, 7 will be as it. Now here 3a is a value of a, 3a plus 4b, 3a minus 4b. Clear? We applied here algebraic identity of a square minus b square. Now that's it. Okay. Now in this case 14 is a perfect square of 4. 144 is a perfect square of 12. But here you can see this is not equal. Here is a5 and it is a x cube. What is happening? So remember this is x. Okay, this is a. That now we can take common. If like that there is equation, then you can take x2 as a common, x3 as a common. Now how much? 4 4 is 16. I think 16 nines are 9 6 are 54 5 9 5, yes 69. So 16x cube, and here we will have how much? x2 minus 69 and x cube, this both are same. It will be as it. Now 6x cube, x square it can be written as x raised to power minus, it is a perfect square 3. Clear? Now in next step it will be as it. Here it is a value of a x plus 3, it is a value of b. Now what else? X minus 3. Here we applied algebraic identities. Here this is answer. Now next over here this is question. In this question we can take it is a perfect square of a square, it is a perfect square of b square. Now in this case 3 3 is a 9 and x multiple x, 3 multiple 3, x multiple x, y multiple y. So 3xy is the perfect square of 9x square it is a perfect square of 3xy. Okay. Now 14 is a perfect square of 4. Now this question is very easy. So it can be written as like that. Now when you will multiply this two times, you will have this. 4 4 is 16. We will apply here algebraic identities. Which one are algebraic identities we will apply here? A square minus b square. So here 3xy plus 4 and 3xy minus 4 minus 4. Clear? Clear? This is answer. Now in this question, it can be written as a square. Meaning of this is what? A square into a square will give a raised to power 4. Meaning of this is what? It is telling you that you will write this two times in multiplication. Then b square into b square will provide b raised to power 4. As you know, it is the value of a and it is the value of b. Here algebraic identity is coming into picture. Which one algebraic identity is? A square minus b square. So a square plus b square. Okay. Now a square minus b square. We have applied algebraic identities here. Not till here, it is the correct answer. It is the correct answer. Further, you can solve it. If you solve it further, then you will get this much. Same. Now next question. Next question will be different from the previous, but little difference. There will be little difference between this and now upcoming question. Upcoming question. Now this is question. I would like to write a more question so that we can solve without any barrier. This is our question. In this question, we will apply a splitting method. Just a split middle term. A split middle term. We will do like that when there are not a perfect square of both sides of both terms of first term and last term. This is a perfect square of x, but it is not a perfect square of any number. That's why in that case we will apply a splitting method. By using a splitting method, we can factor it. So apply a splitting method when you are observing that we are not getting perfect square of both terms of first term and last term. Then you can apply a splitting method. Then you can factor. Look at here, x square as a middle term, a split middle term. As you know, 15, it can be written as 3 5s. Now 5 plus 3 will give 8. You can write 5x plus 3x. Clear? Now 15 as it. Now you can see we have 4 terms. And here in this two terms we have what x common, x as a common, x plus 5. Yes, we can write this here. Now what is happening, if we write here 3 multiple x will give 3x, 3 multiple 5 15. Till here it is correct. Outside terms are 3 plus x, 3x plus 3. Now here these are two brackets which are same. We will write only one time, only one time. Now that's how we did factor it. So we did factor it by using a splitting method. Then it was possible. If you apply, if you wanted to apply algebraic identity, then it will be impossible to solve, to simplify it further, to factor it further. That's why to simplify it further, we can use what, a splitting method. Now next, now here x square is the perfect square of x, but 56 is not perfect square of any number. X square plus now 56 two twos are 2 8s are 2 42s are 20, 2 7s are 7 1s are. Now I think 2 2s are 4, 4 2s are 8 7 15. So here addition of 8x plus 7x will give us how much? Will give us 15x. Now when we will multiple 8, when we will multiple 8 by 7, it will give us 15 6. Now 56 as it, x is a common, x plus 8. It can be written as here same. You have to think of that number which can be written here by this. When we will multiply this unknown number with this, should give this much number, and then when we will multiply this unknown number with this, should give this much number. So what is that number? Only 7, 7x and 8 7 is 56. Now outside terms are x plus 7 and x plus 8 as it. Till here this is a correct answer. Till here this is correct answer. In this case, in this question, again, oh hold on, p square plus 6p minus 16. P square is the perfect square of p. 16 is the perfect square of 4. But if you are able to apply algebraic identity, then you can see. After applying algebraic identities, you are not able to solve, then just use a splitting method. Let's use your method. You want to apply algebraic identity, then let's see. Okay. Now, 2 multiple, let's leave it for few seconds. It is a 4 square. Now 2 multiple p multiple 4. Now here you can see this is incorrect. Here we cannot apply algebraic identity because of 2 multiple 4. It is giving us 4 to the 8p, but it is how much? 6p. That's why anyhow we cannot apply algebraic identities. That's why in that case we have to apply another method. But in that question we can use a splitting method. Then it will be possible to factor it, to simplify it. Okay, so we saw that after applying algebraic identities we are not able to solve it further. That's why we will not solve it by using algebraic identities. Now we will apply what? We will apply a splitting method. We will apply a splitting method. P square 16. 2 8s are 2 4s are 2 2s are. Now here 2 2s are 4, 4 2s are 6. Yes. Is question correct or not? Yes, this is question. This is question which is correct. Now here, 2 2s are 4, 4 2s are 8. 8 minus 2 will provide 6p. So 8x minus 2x. It is correct. Clear. And 8 2s are 16. So 16 1 is 16. It is 16. And now 8 2s are 16 is giving us 16. Now here, what is happening? Here is not a p. Here is a p. Okay. P is a common. P plus 8. It can be written as here same p plus 8. Now minus 2. 2p minus 2 multiple p minus 2p. Minus plus minus 2 8 is 16. Clear. P minus 2 are outside terms. P plus 8. Clear. This is complete answer. Now next question. This is question. Here 12 is not a perfect square of any number. That's why let's apply a splitting method. X square as it 12. 2 6 are 2 3 are 3 1 are. Clear. Now here 4 2 2s are 4 and 4 plus 3 is giving us 7. Can we write 4x minus 3x? Yes, 4 3s are 12. Okay, minus minus plus. Now here plus 12 as it, x is a common, x minus 4. Now x minus 4 as it, minus 3 multiple x minus 3. Minus minus plus 4 3 is 12. X minus 3. X minus 4 as it. Till here, this is correct answer. We did factor by using a splitting method. Now next question. This is the next question. Same here. X square as it and 24. LCM of 24 would be 2 6 2 3 3 1. Now we want minus 10. So it will be possible when the 2 to the 4. 2 to the 4. 2 to the 4. And 3 5. 3 to 5. 2 to the 4. 4 to the 8. 3 to the 6. 6 to the 12. So can we say minus 12 minus 2x minus 12 minus 2x plus 24. 12 to the 24. 3 to the 6. 6 to the 12 and minus 2. Yes, it is correct. It is correct. Till here this step is correct. Now x is a common in this two terms. In this two terms, x minus 6. No, 12 only 12. 12x minus 12. Now minus 2 multiple x minus 2x minus minus plus 12 to the 24. Outside terms x minus 2 and these are same x minus 12. Clear? This is answer. Clear? Next division of a monomial. Division of a polynomial. Yes. Next question. You have to solve it. It is very easy. Just factor each polynomial. Now here we are solving this. It can be written as 2. Otherwise you can say 10 to the 24. And now minus 2. x4 can be written as x2 multiple x2. And x2 is in place of a denominator. This will cut by this. Now we have minus 2x square. That's how you will simplify any division, any fraction which are in polynomial, which are in variables. That's how you will solve. Now next. What about this? Now here you can see 7 will cut this 14 by 2. Here x, 1x, 1y, 1y, 1z, 1z. We have left how much? X, y, z upon 2. In place of a denominator only there is a word, there is a one number which is 2. In place of a numerator is x, y, z. Till here this is answer. So here we simplified a fraction which are in variables. Now next question. You have this question. You have this question. Now here, in this we can take 5z as a common. No, only 5 we can take as a common. So z multiple 5. Clear? Now z square minus 12 8 z 12 5 z. I think not 12 5 z. 16 5 z, let's see. And 5 3 8. Yes, 16 5 z. 16 5 z. So here would be 16 upon 5z into z minus 4. This will cut by this. We have how much? It is a perfect square of z. It is a perfect square of 4 upon z minus 4. Now I am simplifying it here. It can be written as z minus 4 into z plus 4 upon z minus 4. Isn't it? Now this will cut this. This will cut this. We have left z plus 4. We simplified it by doing that. Whatever is cutting, you cut, but logically you have to cut. As you can see, here is in place of numerator z5 and in place of denominator is 5z. So both are same. That's why I cut this both. Here we applied algebraic identities. Which one? A square minus b square. Okay. From this, as you know, it is what? Z minus 4, z plus 4, z minus 4, it is the same. Z minus 4 is in place of a denominator. Here, in place of a denominator is what? Z minus 4. Both will cut to each other. Did you understand?